For day 3, I'm going to add 3 new conditional statements to be used in our proofs later on to your repertoire here. Okay? These are long ones, wordy ones for no reason. Unfortunately, these are just things that you have to have memorized. I'm going to highlight them for you. You got to be able to convey the meaning of these conditional statements when we write them in a proof eventually. They are things, however, that are kind of commonsensical if we think about them. The first one is 2 lines that are parallel to the same line are parallel to each other. I'm going to color code like my hypothesis and my conclusion here kind of. So it says if 2 lines are parallel to the same line. So I have B parallel to C and I have A parallel to C. Then, in conclusion, they are parallel to each other. A must be parallel to B. In conclusion. And we kind of get that. That makes sense to us, right? It's just a big, long way of saying that. My next conditional statement says 2 lines that are perpendicular to the same line must be parallel to each other. My hypothesis here is that if 2 lines are perpendicular to the same line, so I have this line M perpendicular to T, I have N perpendicular to T, then, in conclusion, they are parallel to each other. Questions on that one? Again, if we were using this in a proof, we would be writing this thing highlighted in green in our proof reason column. Then the last one here says that if I have 1 line perpendicular to one of 2 parallel lines, it must be perpendicular to the other line. So my hypothesis states I have a line perpendicular to one of 2 parallel lines. So L and M are thought to be parallel. N is perpendicular to one of them, to line L. Therefore, N must also be perpendicular to M. How do I make this go away? Oh, that's not what I wanted to do. This? There it goes. Go away. Okay. Oh my gosh. Okay. Questions? Okay. This is nice and fun. I like this. What we're going to do here in these examples is we're going to look at a conditional statement. It's only half of a conditional statement, which means I have the hypothesis. And I'm going to draw a nice little picture. It's going to be a nice calming little class. We're going to draw pictures today. So this says, if lines A and B are parallel and line C is perpendicular to line A, then what can we conclude and what is the reason? So I'm going to take this apart piece by piece. I have lines A and B parallel. So let's just draw 2 parallel lines. They don't have to be anything fancy. Here's A, here's B. They're parallel. The rest of my hypothesis says line C is perpendicular to line A. When I draw my diagrams out here, I'm going to make sure that if C is perpendicular to A, I'm also going to extend it through any other lines that I possibly can. That's going to help me come up with my conclusion in a second. So C and A are perpendicular. Then what can I say about this diagram? What can I conclude? Caitlin? Perfect. Then we must be able to say that C is also perpendicular to line B. It looks like that if I draw my diagram right? So we'll say C, perpendicular, upside down capital T shape, to B, by, and I have this whole proof reason that I'm going to use here. It says, if one line is perpendicular to one of 2 parallel lines, I should write this out, one of 2 parallel lines, it implies it is also perpendicular to the other line. And like literally that is the entire proof reason that we have to write here. Questions on that? Okay, let's do the same thing. I'm going to break apart my hypothesis here. If line X is parallel to line Y, maybe I go crazy and I'm going to draw them this way this time. There's line X. There's line Y. They are parallel. Line Y is parallel to line Z. Then what can we conclude? Casper? Which one is parallel to line X? Yes. This is like our transitive property of parallel lines. X must be parallel to Z. If they're each parallel to the same line Y, they must be parallel to each other. That proof reason, again, a long one. Two lines parallel to the same line imply they are parallel to each other. Questions on that one? Number 3, same deal. If line M is perpendicular to line K, let's draw M. Let's draw K. They are perpendicular. Line C is perpendicular to line K. Then what do we know? Anna? We know that already. That was in our statement. Yes, line M and line C are parallel. By our reasoning, it's this middle one here. Two lines perpendicular to the same line imply they are parallel to each other. Okay, any questions on this? It's all about drawing these guys. A little creativity. All right, flip it over. More drawing here. This is what a lot of your homework is going to look like. Actually, not a lot of your homework, but a decent amount of your homework will look like this. It says A, B, C, and D are distinct lines in the same plane. We're being told about the relationships between A and B and C and D. We are trying to figure out for each of these universes of lines, how are A and D related? Guess what? Your answer is either going to be that they are parallel or they are perpendicular. We have no other option. You kind of got a 50-50 shot here. What I'm going to do, I'm going to color code this just a little bit, is I'm going to take each piece of information that I have and draw it out, just like I did in those last ones. Starting with number 1, the first thing I'm going to do is I'm going to draw A parallel to B. Then I'm going to draw B parallel to C. And then lastly, I'm going to draw that C is perpendicular to D. Again, if it's perpendicular to one of these guys, I'm going to make sure that that line D goes all the way through any other lines that it can. Then my question is asking, well, what's the relationship between A and D? And if we drew it nicely, we should be able to visually see what the relationship between A and D is. Do we see how they intersect like this? So they must be perpendicular. And that's my answer. I don't even have to go and justify it unless it asks me to, which it doesn't. Any questions on that? Okay, let's do another one. Again, I'm building this universe of lines here. I have A perpendicular to B. A perpendicular to B. I have B parallel to C. And then I have C perpendicular to D. What then is the relationship between A and D? You got a 50-50 shot. It's 50-50. Which one is it, Casper? Yeah, they're parallel. Look at them. They're side by side like that. They're not crossing. They're parallel. A parallel to D. Okay, can we try 3 and 4? Draw those pictures out. Figure it out. We'll go over them in a second. All right. I drew out some diagrams here. Yours might not look exactly like mine. That is totally fine. As long as you have followed the rules of what this is telling us to do, your diagram's probably all right. For number 3, what's the relationship between A and D? Casper. Yeah, perfect. A and D are perpendicular. Not trying to trick you here. There's only 2 options. What about number 4? What's the relationship between A and D? Caitlin. Hello? Yes. Perfect. Any questions on that? Okay. All right. Next topic here. Kind of a right turn. I don't know why they're in the same lesson, but that's fine. Number 1 says, how do you know when lines on a coordinate plane are parallel? Yeah. Same slope, different y-intercept. Exactly. What do they look like on a graph? Do they ever cross each other? No. So, for example, if I were to draw a line like this with a slope of 2/3, a parallel line to this guy would have the same slope, 2/3, but it would intersect at a different place. Let's maybe put it over here. I don't even know. So also a slope of 2/3. I could mark these as being parallel. They have the same slope, different y-intercept. Number 2 says, how do we know when lines on a coordinate plane are perpendicular? By that same idea. Yeah. Yes. They have opposite reciprocal slopes. And they intersect at a right angle. What is an opposite reciprocal slope? What does that mean? Yeah. That's the reciprocal part. What does the opposite part mean? Perfect. So it's flipped, and then one is positive, one is negative. So in my diagram here, I have the slope is 2/3. What would the slope be of a perpendicular line to these 2 lines? If I want it to be opposite and reciprocal, what would my slope be? Casper. -3/2. So I want down 2 over 3, or sorry, down 3 over 2. Let's put it here. Ooh. So the slope of this line is -3/2. It forms a right angle with each of those lines. Any questions on that? Oh. So in these next few examples here, I'm given some coordinate points. They represent the end points of 2 lines, line AB and line CD. How am I going to figure out, are these parallel, perpendicular, or neither? What do I have to find? Caitlin? And do we have a formula for slopes that we know of? M equals? Anybody remember? Well, it's rise over run, right? So rise is the change in y values, aka y2 minus y1, over the change in x values, x2 minus x1. That is our slope formula. If you do not remember how to find a slope, you need to remember how to find a slope real fast. Okay, so let's do this example. In letter A, I'm figuring out are A, B, and C, D parallel, perpendicular, or neither. I'm going to label mine because I'm nitpicky. I'm going to label this as x1, y1, x2, y2. I find this helps me not get confused when I'm putting my points into my equation. The slope of this first line is y2 minus y1 over x2 minus x1, which is a negative number already, so it's really like plus 3. I simplify. To get my first slope is negative 1/2. I'm going to do the same thing for my other line, CD. I'm going to label x1, y1, x2, y2 to make sure that I keep it all together. y2, negative 6, minus negative 3, which is really a plus 3. x2 is 1, minus negative 5, which is really plus 5. And simplify. So here's my two slopes. What can we say about these two lines? Casper. Why? Same slopes, so they're parallel. If you wanted to write this out a little bit, nicer, we could say AB parallel to CD. That would be the correct notation here. Okay, can we do B and then we're done? Same deal. I'm going to take my first 2 points, the slope, 4 minus 1 over 3 minus 2. For letters C and D, 0 minus 1 over 1 minus negative 2. What do we think about those two slopes? Parallel, perpendicular, or neither? Casper. Why? Perfect. So let's say AB, perpendicular to CD, because they have opposite reciprocal slopes. Okay, questions on that? All right, nice and easy today. Go ahead and get started on your homework.